The ocean covers more than 70% of Earth's surface, forming a vast and continuous body of water that connects every continent and quietly shapes the planet's climate, weather patterns, and long-term environmental balance. Despite centuries of exploration, scientists estimate that more than 95% of the ocean remains unexplored, leaving most of its depths unseen, unmapped, and filled with mysteries that humanity has yet to understand. The deepest known point in the ocean, Challenger Deep in the Mariana Trench, reaches nearly 11 kilometers below sea level, where pressure becomes so extreme that it would instantly crush most conventional submarines. The ocean is constantly in motion, driven by wind, gravity, Earth's rotation, and temperature differences, creating surface waves, deep currents, and slow-moving circulatory systems that operate over thousands of years. Ocean currents act like invisible highways beneath the water, transporting heat, nutrients, and marine life across enormous distances and helping regulate global temperatures. The sound of the ocean is a complex blend of wave motion, shifting ice, underwater geological activity, and distant marine life, producing a natural rhythm that many people find deeply calming and soothing. More than 80% of all volcanic activity on Earth occurs beneath the ocean surface, where underwater volcanoes quietly reshape the seafloor without ever being seen. Sunlight only penetrates the uppermost layers of the ocean, and beyond a certain depth, complete darkness dominates, creating an environment where life adapts without relying on vision. Many deep-sea creatures generate their own light through bioluminescence, using chemical reactions in their bodies to glow softly in the darkness for communication, camouflage, or attracting prey. Water pressure increases rapidly with depth, and at just 1,000 meters below the surface, the pressure is already more than 100 times greater than at sea level. The ocean floor contains vast mountain ranges known as mid-ocean ridges, forming the longest continuous chain of mountains on Earth, hidden entirely beneath the water. The ocean plays a critical role in absorbing carbon dioxide from the atmosphere, helping to slow the pace of climate change while gradually altering its own chemistry. Tides are caused primarily by the gravitational pull of the moon, creating a gentle and predictable rise and fall of sea levels that has occurred for billions of years. Whales use low-frequency sounds that can travel across entire ocean basins, allowing them to communicate over distances that would be impossible on land. The average depth of the ocean is around 3,700 meters, making most of it far deeper than humans can ever dive. The color of the ocean varies depending on depth, light angle, and microscopic organisms, shifting from bright turquoise in shallow waters to deep blue in the open sea. Marine snow, a slow and continuous fall of organic material, drifts from the surface to the deep ocean, providing food for countless deep-sea organisms. The ocean is Earth's largest habitat, supporting an extraordinary diversity of life forms that range from microscopic plankton to the largest animals ever known. Coral reefs grow incredibly slowly, often expanding only a few millimeters per year. Yet they support some of the most diverse ecosystems on the planet. The gentle rocking motion of ocean waves can naturally slow breathing and heart rate, which is why many people feel relaxed near the sea. Even when the ocean appears calm, powerful currents continue to move beneath the surface, carrying energy and nutrients across vast distances. Some underwater canyons are deeper and longer than the Grand Canyon, carved slowly by underwater landslides and sediment flows. The ocean has existed for billions of years, forming as Earth cooled and water vapor condensed into massive basins. Many deep-sea species grow very slowly due to cold temperatures and limited food availability, sometimes living for decades or longer. Ocean waves can travel thousands of kilometers across open water before reaching distant shores, carrying energy from storms far away. The ocean floor remains one of the least mapped regions on Earth, with many areas known only through sonar and indirect measurements. Some fish can detect Earth's magnetic field, allowing them to navigate accurately across vast stretches of ocean without landmarks. The ocean stores more heat than the atmosphere, acting as a massive thermal reservoir that stabilizes global climate systems. Underwater earthquakes can generate tsunamis, powerful waves that move silently across the ocean before rising dramatically near land. The ocean surface reflects the sky, often appearing peaceful and endless, while concealing immense depth and movement below. As sunlight slowly fades with increasing depth, the ocean transitions through a wide spectrum of blue tones, creating a gradual shift from brightness to darkness that gently alters how life adapts and moves within these layered environments. The ocean plays an important role in moderating temperature differences between day and night, especially near coastlines, by absorbing heat during the day and releasing it slowly after sunset. Marine life has evolved extraordinary physical and behavioral adaptations that allow survival under intense pressure, near freezing temperatures, and complete darkness in the deep sea. The vast scale of the ocean allows entire ecosystems to recover gradually over long periods of time, often balancing themselves naturally without sudden or dramatic change. The sound of distant waves and flowing water can help reduce stress and anxiety by encouraging slower breathing patterns and gently calming the nervous system. Wind patterns continuously shape the ocean's surface, transferring energy across vast distances and creating waves that travel quietly far beyond their original source. Some deep-sea creatures live their entire lives without ever encountering sunlight, relying instead on chemical energy, pressure-sensitive sensors, and slow metabolic processes. The ocean stores memories of Earth's past climates within its chemical composition and layers of sediment, preserving a quiet record of environmental changes over millions of years. Differences in water density caused by temperature and salinity drive powerful yet slow-moving circulation systems that influence climate and marine life across the planet. The ocean's constant and gentle movement creates a sense of flow and continuity that many people find mentally soothing and grounding. Many marine organisms rely more on chemical signals than vision to understand their surroundings, especially in environments where light is limited or entirely absent. The immense pressure found in deep ocean environments shapes every aspect of life there, influencing body structure, behavior, and survival strategies. The predictable rise and fall of tides has influenced biological rhythms across countless species, synchronizing feeding, migration, and rest cycles. Ocean currents connect distant ecosystems by transporting nutrients, larvae, and energy across vast stretches of open water. Underwater landscapes can rival those found on land in size, complexity, and beauty, featuring mountains, valleys, plains, and canyons hidden beneath the sea. During daylight hours, the ocean absorbs large amounts of solar energy and releases it slowly at night, helping stabilize temperatures across coastal and marine environments. Deep sea life often evolves slowly due to stable environmental conditions, limited food supply, and minimal external disturbance. The immense scale of the ocean can create a feeling of calm, humility, and perspective, gently reminding the mind of the vastness of the natural world. Some ocean currents move so slowly that their full paths are measured over decades or even centuries, shaping climate patterns quietly over time. The chemical balance of seawater supports complex and interconnected food webs that sustain life from microscopic organisms to large marine animals. Marine environments often operate on timescales far longer than a human lifetime, with changes unfolding gradually across generations. The gentle motion of water can naturally encourage slower breathing and relaxation, which is why ocean environments are often associated with rest and sleep. Pressure, darkness, and cold combine in the deep ocean to create one of Earth's most extreme yet stable environments. The ocean remains one of the planet's last great unexplored frontiers, holding countless forms of life and geological features still unknown to science. Waves and tides create repeating rhythms that continue endlessly, shaping coastlines and influencing life with steady, predictable motion. Deep ocean waters remain remarkably stable, even as surface conditions change rapidly due to weather and seasonal shifts. Many marine species have evolved in isolation over millions of years, adapting slowly to their unique underwater environments. The ocean's constant movement exists alongside deep stillness, creating a balance between motion and calm that defines life beneath the surface. sound of water, whether through waves or distant currents, can help quiet racing thoughts and bring the mind into a relaxed state. The vastness of the ocean invites reflection and mental rest, offering a sense of openness and calm that mirrors the slow rhythm of nature. Deep ocean layers change very slowly over time, maintaining stable conditions that allow life to persist without sudden disruption. The ocean connects Earth's past, present, and future through continuous movement, circulation, and shared environmental processes. Salt in the ocean comes primarily from minerals carried by rivers over millions of years, gradually accumulating in the water. Deep sea environments remain near freezing temperatures year-round, yet specialized life forms continue to thrive there. Ocean circulation patterns can take centuries to complete a full cycle, slowly redistributing heat and nutrients across the planet. The pressure and darkness of the deep ocean create one of the most extreme environments on Earth. The ocean absorbs much of the energy from storms, reducing temperature extremes across continents. Some marine animals have evolved to sense vibrations in the water rather than relying on sight or sound, allowing them to detect movement, predators, or changes in their environment, even in complete darkness far below the surface. The ocean influences weather patterns by slowly releasing stored heat and moisture into the atmosphere, shaping winds, storms, and rainfall across continents over long periods of time. For thousands of years, coastal tides have guided human navigation, fishing practices, and settlement locations, quietly shaping civilizations long before their scientific causes were understood. The deepest parts of the ocean remain largely untouched by human activity, not because they lack importance, but because the extreme pressure and darkness make exploration incredibly difficult. Geological time, the slow and continuous movement of ocean water reshapes the seafloor, carving valleys, building ridges, and redistributing sediments across vast underwater landscapes. Many marine species migrate across entire oceans, following subtle changes in temperature, light, and food availability that shift gradually with the seasons. The ocean's constant motion creates a steady background rhythm that many people subconsciously associate with calmness, stability, and mental relaxation. Underwater mountain ranges influence not only the flow of currents around them, but also the distribution of nutrients and marine life above their peaks. Ocean surface temperatures vary widely depending on latitude, season, and current patterns, creating distinct marine regions across the planet. Some deep-sea organisms have adapted to survive entirely without sunlight, relying on chemical energy or organic material drifting down from above. The ocean connects distant ecosystems, allowing species and nutrients to travel across the globe in ways that continue to shape life on Earth. Although waves appear to push water forward, most of their motion occurs in gentle circular patterns that transfer energy rather than moving water long distances. Coastlines are continuously reshaped by the ocean through erosion and sediment deposition, slowly changing the boundary between land and sea. Many marine species communicate through subtle changes in movement, pressure, or chemical signals rather than audible sound. The vast scale of the ocean can create a sense of perspective that quiets the mind and reduces mental tension. Sound travels much farther underwater than in air, allowing marine animals to communicate across immense distances in the open sea. The chemistry of ocean water directly influences which organisms can survive in different regions, shaping entire ecosystems. Deep ocean currents flow independently of surface conditions, driven by differences in temperature and salinity that create slow but powerful circulation patterns. The rhythmic patterns of waves and tides have inspired relaxation practices and sleep aids across cultures for centuries. Marine ecosystems depend on delicate balances that can take decades or even centuries to recover once disrupted. The ocean reflects and absorbs sunlight, playing a key role in regulating Earth's overall energy balance. Many marine animals are perfectly adapted to withstand pressure levels that would be instantly harmful to humans. At great depths, the ocean becomes almost silent, broken only by faint geological movements and distant biological sounds. Coastal environments shift continuously as tides rise and fall, subtly altering habitats on a daily basis. The ocean preserves records of Earth's ancient climates within layers of seafloor sediment that accumulate slowly over time. Some underwater regions remain completely unexplored due to technological limitations and extreme environmental conditions. Life in the ocean operates on multiple timescales, from daily tidal cycles to evolutionary changes spanning millions of years. Slow-moving deep currents create stable environments where life evolves gradually over long periods. The ocean's depth creates distinct layers, each with its own temperature, pressure, and unique forms of life. Many species depend on ocean currents to transport their offspring across vast distances to suitable habitats. The steady movement of water contrasts with the apparent stillness found in the deepest parts of the ocean,